Welcome you all. So from the 7th chapter integrals, we have completed exercise 7.1. So we got the integral by applying inspection method, direct formulas. And from exercise 7.2, we have solved 3 questions by applying substitution method. So first substitution and then by inspection, we got the integral of the function. So from now, we will solve the 4th question. Question number 4. Sin x into sine of cos x. So this is the function they have given. We have to find the integral of this function. So integral of sin x into sine of cos x. So since here the independent variable is x, so we will write dx. Okay, so we have to find the integral of this function. So this cannot be solved by an inspection method. So we have to go for the substitution method where both function and its derivative will be in the integrand. So we know in substitution method, so when we have function and its derivative in the integrand, we will apply substitution method, right? So if we differentiate sin x, you will get cos x. If you differentiate cos x, you will get minus sin x. So both of them are in the function. But now which one to take for substitution? Whether you should take sin x is equal to t or whether we have to take cos x is equal to t. So we have to do the substitution in such a way that all the x will be transformed to t. Any function with variable x must be in the form of the variable t. Then we say that our substitution method is correct. So here which one to take as a substitution, whether we should substitute sin x is equal to t or cos x is equal to t. So here if you take sin x is equal to t, so let us just experiment once. So if you take sin x is equal to t, now you differentiate with respect to x. So derivative of sin x is cos x. And if you differentiate t, you will get dt by dx. Now this will be cos x dx is equal to dt. So you might think that cos x dx will be equal to dt, right? But that is wrong because cos x is a part of sine here. So cos x is inside sine. So here we cannot substitute cos x dx is equal to t. So that means we are unable to transform this x variable in the form of t. So hence we have to choose the right function for the substitution. So we will not take sin x is equal to t, we will take cos x is equal to t. Let cos x is equal to t. Now we will differentiate with respect to x. So if you differentiate cos x, you will get minus sin x and this is dt by dx. So we have to substitute for sin x dx, right? So we will cross multiply this. So sin x dx will be equal to minus dt. So sin x dx will be equal to minus dt and in the place of cos x we will write t. So the substitution is done successfully because all the x terms now are in the form of t. So therefore, integral of, we will write this as sin t and sin x dx, we will write it as minus dt. So this implies, so let us take minus 1 outside. So this will be sin t with respect to t. Now this implies minus 1 into, so integral of sin x is minus cos x. So integral of sin t will be minus cos t. So since we have done the integration, we will write the constant c in. So this implies minus times minus is plus cos t plus c. So this is the integral of the given function. But here we have to transform from t to x. So therefore, we'll write the final step, integral of sin x into sine of cos x dx is equal to, so in the place of t, we have to write cos x plus constant of integration. So this is the integral of the given function.